my dear students. In this week, we will discuss about some mathematics and problem solutions of AC circuits, of balanced three-phase circuits. So, why we say that will be a balanced phase? When balanced phase voltages are equal in magnitude and they are out of phase with each other by 120 degree. So here we can see they are each of the phase voltages. There is a diagram, phase sequence diagram. Each are apart from 120 degree, and there are phase voltages. That means Y connected. That is Y connected voltage, and from this we can understand what is Y connected voltage 12.6. If we just see here, there is a Y connection of voltage. So each phase, this kind of things are phases. That is neutral point, that has been denoted as N. So if the voltage is A to N, neutral, phase voltage to the neutral voltage, so that will be a phase voltage, phase to neutral, and there is another phase to neutral Cn, there is another phase to neutral Bn. So Van, Bn and Cn all are the three phase voltages, and that are Y connected source, and they are each other 120 degree apart from each other, and there are two common phases, that common sequence that we should follow, that are known as the positive sequence and negative sequence. Here you can see Van, Cn and Bn. That means it is an ACB format, that is known as the negative sequence, and there is an ABC format, and that will be a positive sequence. It is known as the positive sequence. Why it is known as positive or negative? First of all, just look at it. Look at here. You can see here that is A, B and C, ABC sequence. Why it is known as positive sequence? Because the rotation are the in the favor of the anti-clockwise direction. As we know, clockwise direction will be this, and anti-clockwise direction will be that. So anti-clockwise direction are always recommended as positive direction, and clockwise directions are always recommended as negative direction. As we can see here, there is minus 120 degree. That means that is on the negative side, and the two parts are differ from 120 degree and minus 120 degree. So ACB will be negative sequence and ABC will be positive sequence. So we can now understand the positive sequence and negative sequence. And balanced phase voltages means that the magnitude and the phase is equal to each other. And then we can see that how the phase voltages are also defined as part as the phasor diagram. As we can see, VP, that is 0 degree, then VBN, it will be minus 120 degree. Here you can see minus 120 degree at this sequence, and later on we can find out VCN, that will be plus 120 degree. Here you can see it is VCN, that's plus 120 degree, and here you can see that's minus 120 degree. This plus 120 degree can be also defined as 240 degree, as it is known as that from A to B, if we say AN as 0 degree, so the CN will be 120 degree apart, and BN will be 240 degree, 120 plus 120, 120 plus 120, 240 degree apart from each other. So there are some basic knowledge that we have to know to just make solutions right. Now there is another sequence of the ACB sequence. In that sequence, the VCN will be minus 120 degree, and the VBN will be minus 240 degree, and that is known as the negative sequence. Okay, and as you can see, it will be, if it is minus 240, that can be written as plus 120 degree. In that sense, I can also say that can be possible. If you see that the negative sequence, please see here the negative sequence, that will be 240. That means if you just go through to the nominal way, that will be minus 120. You can write both, because in these phase You can go through here and you can go through here too. Both sides are open, so you can say that will be 120, 120, 240 degrees according to the negative sequence, and you can also say that minus 120 degree, as you can say. That can be possible here to understand this. So these are the many basic things that's regarding on the ACB and ABC sequences, that is known as the phase sequence. If anybody asks that what is the phase sequence, the phase sequence is a time order in which the voltage pass through the respective maximum values. That means if it is a sinusoidal voltage or current waveform, you can see in each phase, that means this is a phase sequence, that is a phase sequence, that will be a phase sequence. Each time they will pass through different angles and with their maximum values. This is the maximum values of Vp, that's the maximum value, and there will be maximum, we have minus Vp. So to this minus Vp plus Vp to minus Vp, we know the distance between these two are 90 degree are 180 degree apart, because we know that is 0, that is 90, that is 180, and that is that is 270, and that is 360. So this 90 and 270, it will be 180 degree apart from each other. So it is a two-phase system. It will be, if it is a three-phase system, so each of the waveforms will be apart from 120 degree. If it is from a voltage phase voltage from 0 degree phase sequence is here. If it is 120 plus 120 degree, so that is 90 degree. So just 90 plus 30 means 120 degree. That will be start from here. That is the next phase that starts from here. And if it crosses another 120 degree, that will be start from here. That will be the VCN. So three phases will start on different time, different angular zone, and different phases. They will start their proceedings. So that means that they are in different time orders. It is pretty much simple, because when we see the factor of this the thing is that just like this 120 degree and 240 degree apart from each other. Why that will be happen? Because as it is three phase, that means there are three terminals are there, A terminals, the B terminals, and the C terminals, and each are 120 degree apart from each other. So while this magnet passes through from A side to C side, so it will take 120 degree later to respond another phase, another current and another voltage will be passed through this. First of all, if it crosses through this bar, that will go through to this, we can get voltage in that position. When it passes through the C position, that we will get another voltage passes through that position, and the angle between these two phases are 120 degree. So the phase will start from different angles. So first of all, if it is crosses through A, that means that will be a VAN waveform, and if it passes to 120 degree, so it will take time to get start from 120 degree from here. So if it is passes through to the CN, so then after 120 degree, the VCN will start flow from here, and after 120 plus 120 240 degree, if you just draw the diagram around 240 degree, and then it will be start VBN. So that is the basic thing to the three phase sequence generations, that how the sequence will be generated. So in the next lecture, I will draw your attention that how you can understand the balanced AC circuits from this lecture.